Welcome back to Hot Mess Science. I'm Mrs. Nickles and my assistant is...
Eddie Nickles?
That's correct, Eddie Nickles. And today I'm going to bring us through a larger exploration of matter. And what is matter, Eddie?
Matter is the stuff that makes up everything.
Yep, the stuff that makes everything up, how scientifically put, right? So when we're looking at matter, there are two major changes that we can observe that matter goes through. And what are those two changes?
The two changes are physical and chemical.
That's right, yeah. And so that's something that we've talked about already this year in our class, is that when we observe a change in matter, we really have to be detectives to look at clues and indicators that let us know, has that substance just changed form, a physical change, or has that substance actually changed into something new? And if it changes into something new, we have a chemical change, a new substance with new properties. So what I'd like to do today is have 6 experiments going. So this might be a little bit longer than usual, but I want to do 6 different changes in matter, and I'd like you to be able to look carefully and really evaluate what's happening in each of these circumstances. What are your indicators? What evidence do you have that the matter has stayed in its the same substance but a different form, physical change, and what evidence do you have that it's changed into something new? So we're going to have 6 experiments. I'm going to walk you through each one, and as we go through, I'd like you to look at the end products and then decide, is it a physical change or is it a chemical change? Okay, so experiment 1, I call crayons. And what we are going to do is, our piece of matter is a crayon. And crayons are made out of a colorful wax. And we are going to make a little bowl or pan or boat out of aluminum foil, break off a piece of our matter, our crayon, put it in the bowl, and then we're going to expose it to some high heat. And this is a hot plate, but you can certainly do this in a pan on the stove. You could, making sure you use the foil so that you don't ruin the pan. And you can also do it in the oven. We're going to make little boats. We're going to put that in, and then we're going to make sure that we're being really safe about how we're touching hot things, right? I'm going to put things on the hot plate, right? And then we're going to use tongs to take it off. And then what are we going to wear on our eyes once we put it on the hot plate?
Some glasses.
Can you put them on? We're gonna wear some goggles with our experiments today, right?
They'll get glasses.
Sure. Okay, so what happened to our solid piece of wax matter when we put it in the boat, Ruth?
It melted.
It melted. And then what happened when I took the foil off and let it cool? What happened? Is it liquid? It dried. Yeah, it's not liquid anymore. It's hard now, right? And where did the heat come from?
Hot.
Well, yeah, where did it come from? Can you point? Yeah, the hot plate. The hot plate is where the heat came from. So we added that heat, and this crayon still is crayon, right? I could get a piece of paper and turn this inside out and still get some green color out of that.
Wait, Mama, look, we can peel that
We can
off.
peel it right off, right? Look at that.
There's some paper in there.
Yeah, but it's still crayon, right? It's not a new substance.
Wait, you can still draw with it.
You can still draw with it. So it's a physical change. So experiment number 2 is something I call sugar water, or for people that don't live in Massachusetts, it's sugar water. And this is my assistant, Thomas Nickles. And Thomas is going to help me. We're going to combine two types of matter. We're going to combine water, liquid water, and we're going to combine some sugar, a 1/4 teaspoon of sugar. We're going to stir it up real good. We're going to make some observations, and we're going to determine if it's a physical or chemical change. So, Thomas, what happened when we added the sugar to the water?
It turned like into some sort of like dissolved sugar water. I guess.
Yeah, it like dissolved into the water and it turned into sugar water. And so can you see the sugar anymore?
Yes.
Yeah, a little bit. There's a few granules at the bottom, but most of it you can't see anymore, right? It's clear. So if you put a solid into a liquid and it disappears and it's all clear, it pretty much looks like it's dissolved, right? So did it turn into something new, or is the sugar still in there? We need more.
The sugar's still in there.
It is still in there. Yeah, if you were to drink this, what would it taste like?
Sugary water.
Yeah, it would be sweet. So there are a couple things that we could do to test this out. We could heat the water and evaporate it off and see if we could get the sugar left behind, because evaporating is a property of water. Or we could get more evidence, like taking the temperature. And so we took the temperature of the water before when we were just taking it out of the tap. We had 20 degrees Celsius. And then after we added the sugar, it stayed at 20 degrees Celsius. So there was no temperature change. So when you combine two substances, sometimes if there's a temperature change, it's an indicator that something new has formed. But there was no temperature change. So really, we still just have two pieces of matter, sugar and water. It's just that sugar has the property of being able to dissolve in water. We can get that sugar back, and it still has retained its properties. So even though this one's tricky, it looks like it changed into something different. It really didn't. It just dissolved. So it's a physical change. Okay, experiment 3. I call this H2O2 Soup. And the H2O2 is hydrogen peroxide. You can get that in those brown bottles at any grocery store. So we have 10 milliliters of hydrogen peroxide. It's a clear liquid, not water. Don't mistake it for water. And we're going to combine that in a beaker with a solid called yeast. And this is just regular yeast that you can also get at the grocery store. We're going to put a 1/4 teaspoon of that together. And we'll stir it. And we're also going to make sure that we take an initial and a final temperature, because that's always a nice extra clue. My assistant with me today is
Eddie Nickles.
And Eddie is going to perform the experiment. But first, what do we put on our faces?
The safety goggles.
Safety goggles. Is it physical or is it chemical? So Ed, when we combined the hydrogen peroxide and yeast, what were your observations?
It started to.
What happened?
It started to foam up.
Yeah, it did. It foamed up, bubbles were made. So that means that a new substance was made because the hydrogen peroxide was a liquid, the yeast was a solid, and when they came together, we got a new substance, a gas. And that gas made bubbles. So bubbles and foaming, that's a good indicator of a chemical change. What happened to the temperature, initial and
It
final?
rose.
Yeah, how many degrees?
9.
9 degrees Celsius, and that's significant, right? 9 degrees Celsius is significant. So if we got a temperature change, now do we add heat to this? Did I add anything
No.
hot to this?
No.
No. So I just combined those two substances, and on its own, in its own combination, it went up 9 degrees Celsius. So between the foaming and the temperature change, I can safely say I have evidence for a chemical change. Okay, experiment 4. I like to call this find your inner artist. And so what we're gonna do is I took some regular, just plain water. We're gonna take an initial temperature, and then I have some watercolors. I'm going to make a little design and rinse off my, my paintbrush, and then I'm gonna take a final temperature, and we're gonna see what we have for a physical or a chemical change. Okay, so a couple of things were happening here. I had some clear water, and then I used some paints to make my picture. And every time I changed a color, I rinsed it in the water, and so I had several color changes. Now, often when we see a color change, it indicates to us that a new substance has been formed. But let's really think about what's happened here. This color change, is it predictable? Is it a color change that I would expect to have had happen when I put paint into water? Yeah, it's really just diluted paint. I would have expected that color change to happen. So it's not really a good indicator. It's not really something that was unexpected that would indicate a new substance. So I need more information. So when I took my temperature, it was 19 degrees Celsius in the beginning, 19 degrees Celsius in the end after the color changes. And so because I had no temperature change, I'm pretty safe to say that this is really just, again, a dilution, sort of like the sugar water. And if I were to evaporate the water off, I would end up with some chalky paint on the bottom that I could just scrape off the bottom of the beaker. So even though we had a color change, it was expected. There was no temperature change. It was just a dilution. So I can say this was a physical change. All right, so here we go, experiment 5. This is actually a 2-for-1. I call this iodine, starch, and alcohol, oh my. And so we have 2 test tubes. This one has 10 milliliters of just plain isopropyl alcohol that you could get in any store. And this here is starch solution. It's 10 milliliters of a starch solution. So basically cornstarch and water. And so these are 2 different substances. You have a pure substance here of alcohol, and you have a solution here with 2 types of matter. You have starch that is dissolved in water. And so what's going to happen here is, who's my assistant? Ruth Nickles. And so Ruth is going to see if we can get some sort of a color change indicator. Oh, okay. Well, hang in there for a second. And so this is iodine. And so we've just put a little bit of iodine in this beaker, and Ruth is going to put 3 drops of iodine in each of these substances. Ruth, what color would you say this iodine is? What would you say that is?
Kind of a blackish orange.
Yeah, it's kind of tricky, right? It's like
It kind of looks like wine.
it looks fantastic. So it's like a brownish, reddish, orangish liquid, right? Yeah, okay. So what we're looking for is a change in color in either of these. And I think we should also do a temperature reading.
I can't really breathe.
Breathing is important. How's that? Good. Okay, so we'll take our initial temperatures and then we'll add our iodine. We have 2 different things happening here. Not a lot of excitement with the temperature change, so we can't really rely on temperature as an indicator or a clue in this instance. So we're going to have to look for other clues, other indicators. Let's go to the alcohol first. So what color did we end up getting here? Well, it's kind of like a pale orangey yellow, right? And so is that an expected or an unexpected color change? Well, considering that this is what I started with, which is sort of like that dark orangey reddish, and I added it to a clear liquid, I'm going to say that's an expected color change. That really doesn't indicate to me that there would be any kind of a new substance being formed. So I'm going to call the alcohol test tube a physical change. Over here, I didn't have a temperature change. However, when I added this yellowy, dark orangey red liquid to it, I got something totally different. I got like a cobalt blue, like a dark purple blue color. And actually iodine is used to detect starch. So this was actually a chemical change because this is really a dramatic, unexpected color change. So it indicates to me that a new substance has been formed. So chemical change for starch. Physical, chemical. Okay, so final experiment, experiment 6. We're going to do something that doesn't always get done in the classroom, but it's a real good indicator of a chemical change. So I'm kind of giving things away here. We're going to combine 2 liquid chemicals. One is called copper sulfate, and it's this beautiful blue color. We're going to put that in the test tube and take an initial temperature. And then we're going to do 2 drops of the sodium carbonate, and we're going to make some observations of what's happening there and take a final temperature as well. My assistant in this experiment will be
Eddie Nickles.
Eddie Nickles. And so we're going to really be looking for evidence that a new substance has been formed here. With this experiment, we had a couple of things happening. We had a slight drop in temperature, and in chemistry, when there's a drop in temperature, we call that an endothermic reaction. So that was one indicator. We had substances that were both at room temperature, and yet when we combined them, the temperature went down. So one indicator of a new substance. The other indicator we had was there was these little white solid particles that happened when we combined the two liquids, and we call that a precipitate. It kind of looks like little white snowflakes in a snow globe, or maybe some cotton or wet tissue paper or something. And so that precipitate, a solid forming when there wasn't one before, and we're not exposing it to any cold temperatures or anything. We're not putting it in the fridge to make it freezer to make it freeze. So that drop of 1 degree temperature and this precipitate are both indicators that this was a chemical change. So in the end, if you've been keeping track, out of our 6 experiments, we have this for results. We have a physical change for number 1. We have physical, chemical, physical. Number 5 was that one with 2 test tubes, and one was a physical change with the alcohol in it, and the other one was a chemical change with starch in it. We added iodine to both. And then the last one was a chemical change, and you actually got to see what a precipitate would look like, a solid forming in a liquid. So that is the final results, and it's always important to be able to include your evidence as to how you know it's a chemical change and a physical change.